going to talk about how you find the volume of solids with known cross-sectional area. For example, if you have a cylinder and the radius is R and the height is H. Let's try to draw it nicely. Have a cylinder and the radius is R and the height is H. And let us put some axes down. Let's call this the x-axis. Let's call that the y-axis. And again, the radius is R. Radius is R. Okay. So this y value would be H, because that's the height. Now, if you take a given cross-sectional area with some thickness, okay, well, that's our disk. It's a circle with some thickness. So the change in the volume is clearly pi r squared times delta x. Now the whole volume will delta y, excuse me. That thickness is a delta y. So if we add up all of these cross-sectional areas, what we will get is the integral of pi r squared dy. Now what's y going from? These questions, you have to understand how to answer them, because they're very simple answers. If you ask it right, the first slab is going to happen at a height of 0, and the last one is going to happen at a height of h. Now suppose the radius is 4 inches and I don't know, the height is 12 inches. So what we get is, I'll factor out the constant, is pi times 12 squared times the integral of y, dy, excuse me, and y goes from 0 to h, but h is 12. So let me replace r with 4 and not 12, and we'll be on a roll. So 4 squared is 16 times, or pi, times pi is going to be 16 pi, and times this integral. The integral of y, the integral of dy is just y, which goes from 0 to 12. So you have 16 pi times y from 0 to 12. You plug in 12, for y you get 12. You plug in 0, you get 0. So it's going to be whatever 16 times 12 times pi is. Well, 16 times 10 I know is 160, and 16 times 2 is 32. So it looks like the area is, like I said, 32. Looks like the area is 192 pi. But we can verify this because we know that the volume of a cylinder is pi r squared h. So it's pi times r, which is 4 squared, times h. But that's exactly what we did. I mean, how did we get that 16 pi? We did pi times 4 squared. 16 pi. And then we multiplied it by 12 and we got 192 pi. Okay, in fact, if we just left it the way it was, with, like right here, if we just left it right there and we integrated that without putting in the radius and the height, well, this integral, well, it's going to be pi r squared times that integral, and that integral is just y from 0 to h. So we get pi r squared, plug in h, get h, plug in 0, get 0. What's inside that bracket is just h. Ooh, that's right, I remember now. Why am I saying cone? It's a cylinder. The volume of a cylinder is pi r squared h. Okay, so this actually confirmed the formula. Now, suppose that we have a pyramid. And the pyramid is designed where you have a base. The bases are square, and on top of that square is a little bit smaller square, and on top of that square is a little bit smaller square, and on top of that one's a little bit smaller. So since their squares are getting small, the sides of the squares are getting smaller and smaller, if you keep doing this, you'll get to just a point. And that will be the top of the pyramid. Now, let's see how well I can draw this pyramid. I will not try more than twice. Okay, so that's the base of the pyramid. Actually, just in case I need some more space, let me lower it. So that's the base of the pyramid, and maybe, so the top of the pyramid, that's the dead center right here. This is like the dead center. So the top of the pyramid will be, say, right above it. So maybe it will look something like that. Okay, not too bad. It'll look something like that. Okay, and I'll tell you that the height, remember the height only goes from the floor. The height is h, and the base is 5 inches by 5 inches. Okay, so now we have a cross-sectional area with thickness will look like that. So that's a B prime, well, let's call it B. That's B and that's B. So now the volume, the delta volume, that piece of the volume will just be B squared times the thickness, which is delta Y. Okay, that's going to be B squared times delta Y. Okay. Just thinking if I want to call it something other than B. So the volume is, let's just call it S for side. It's just a letter. So we have S squared Alright, so it's going to be side squared dy. And y's are going from 0 to h. The bottommost rectangle. So we put this on the axes, x and y. Okay, so now the bottommost sphere, the bottommost rectangle, it's going to be at a height of 0. And then you'll get one higher, like the green one. And then at the very top, you'll get one that's at h. That is why we're going from 0 to h. Now, the question is, at a given y value, what is the length of each side? I know one thing. When y equals 0, we'll call it x. The length, well, let's call it s. S is equal to 5. We know that. S is equal to 5. And y is equal to h, and let's say h is 12 inches. So I'm going to make one change here. I'm going to go from 0 to 12. Okay, so when y is 12, the sides are 0. So we need to be able to figure out what the side is for any given y. It's going to be a linear change. It's going to be a linear change. So we know that one point is 5, 0. We're going to do s, comma, y. Lengths of their side, comma, the height. Okay. And another point is, so I got, 5, 0 from here, and now I'm going to get 0, 12. I'm going to get 0, 12. Okay, so let us find the slope. M is going to be from 0 to 12. It went up 12. And then from 5 to 0, the change in y went down 5. So the slope is negative 5/5. And you know what? That's the y-intercept. I know that y is equal to mx plus the y-intercept, which is 12. Now, we should check to see if we're right. Sometimes we make mistakes. What's y of 0? Well, negative 12/5 times 0 is 0. And if you add 12, you get 12. So when x is 0, y should be 12, which is that point right there. Well, what about y of 5? What about when s, oh, sorry, we're not using x, we're using s. Okay, so what about when s is 5? You get negative 12/5 times 5. The 5's cancel, you get negative 12 so far. But then it says to add 12. Yep, you get 0. When s is 5, y is 0. Got it. So we have the right equation. Okay, so given y, we know s. Or actually, sorry, this tells us given s, we know y. We can solve this for s. Well, if you take away 12, you get negative 12/5 s. And then you'll multiply by negative 5/12, and you'll get s. Let us do that multiplication. Negative 5/12 times y, that's easy. That's negative 5/12y. Negative times negative is positive, and the 12s cancel. You just get 5. And that is what s equals. Okay. So now we know s in terms of y. Well, what we want to do is square the s. Well, what happens is we know what s is. It is negative 5/12 y plus 12. That's s. Negative 5/12 plus 5, excuse me. Always double check. Everyone makes mistakes, especially me. Okay, so now this is what we want to integrate right here. So I'm going to copy that. You may not get that 12 copied, but let us bring it down and let's solve this. Let's paste it. So that's going to be the volume. So it's going to equal the integral from 0 to 12. I'm going to say the 5 first. Positive 5 minus 5/12y squared dy. Okay. Well, when you square a difference, it's a routine answer. You get the first squared, you're gonna get the second squared. 5 squared, y squared over 12 squared. Minus, because there's a minus, you're gonna get 2 times the first times the second. Well, the 2 goes into the 12 6 times. So you're gonna get 25/6 dy. Okay, and from here, it's routine. Integral of 25 is 25y plus 25y cubed over 3 times 144. I hate multiplying out, okay, because maybe we can reduce. Minus 25/6 times y, and y goes from 0 to 12. Well, when you plug in 0, it's going to cancel out to 0. So I'm going to have 25 times 12 plus 25 times 12 cubed over 3 times 12 squared. 144 is 12 squared. So that cancels out, leaving just 12. And 3 goes into 12 4 times. Minus 25/6 times 12. And 6 goes into 12 2 times. Now, I notice everything is being multiplied by 12. So I'm going to have 12 of them plus 4 more 12s, 4 more 25s, minus 2 25s. 12 minus 2 is 10, plus 4 is 14. And 25 times 14 is 350. Okay, so that is going to be the volume. Let us do one more cross-sectional problem. Suppose you have a right cone. That means that in the middle of the base, right there, that's right below the top. Okay, you can have a cone, so there's the cone in case you don't see it. There are cones that are not right cones. That's a cone. It's just not a right cone. They're all circles, actually ellipse. Now, plugging in the numbers, if I tell you the radius of this cone and I tell you the height of the cone, it really doesn't make the problem any harder or any easier. So let us draw this nicely. Here is a cone. There it is. The radius is, I don't know, 8 inches. And the height of the cone is 12 inches. 12 inches. Now, and this is a right angle. Let me just draw this again, because I wrote on it a bit. Here it is. Now, let me take a cross-sectional area. Let me take this. But it has thickness. It has thickness. Well, what is the volume of that piece? Call it delta V. Well, it is a circle, so it's pi r squared. And since it's going, the thickness is in the y direction, we'll say dy, delta y. Now, we want to add these all up. There's a continuous amount of them. So, we get V is equal to the integral of pi r squared dy. Okay. Now, we need to be a bit careful about what y equals, what r equals. Because for different heights, r is different. For different heights, r is different. That is, down here, r is 8 inches. R is 8 inches. But for this height, since I'm calling it y, for that height of y, my question is, what is r? Well, it's proportional. Y, this distance, is to r as I want to now say, okay, so we need to be more clear. We can call the we can let this here be the x-axis. We can let this here be the x-axis. That's not a problem. Now, the similar triangles that we get, well, this is one of them, and then the whole thing is the other one. The whole thing is the other one. One is not higher than the other. I just didn't want to draw on them. So now, what we do know is that one height, which is h, just want to see how I want to word this. Okay, so let me just think about it. I see it, just have to explain it. So this length, let's look at the left triangle, the big one. This height is h. And the radius is 8. But now let us look at the smaller one. Let us now concentrate big times on this right triangle right here. This one right here. Okay, now this is at a height of y. So how long is that? Well, we know the whole thing is h, so that's going to be h minus y. This piece in blue now is going to be h minus y. And r, I don't know. So we do height to r. And excuse me, the height is h minus r. Okay. Now what we want to do is solve this for r. So r is equal to h minus y times 8 over h. That is exactly what r equals. Now, let's see if we're wrong. Maybe we're wrong. Who knows? Maybe we're wrong. Well, when y is equal to 0, we want to be down here. When y is 0, we want to be down here. Well, when y is 0, r is supposed to be r times h minus 0 over h, which is 8h over h, which is 8. Yeah, that's right. When r is 0, when y is 0, r is 8. R is 8. Okay, that's just what we wanted. R is equal to 8. What about when y is h itself? So r is, just copying here, r is equal to 8 times our h minus y, which is h, over h. Well, h minus h is 0. Divide it by 8. Sorry, you get 0 over h, which is 0. You mean when y is at the top, the radius is 0? Yeah, the top circle, the radius is 0. This is exactly right. Okay, make sure it's right. So now it says that we want to integrate pi r squared dy. We want to integrate pi r squared dy. Integrate. So it's pi times r squared dy. But r from right here is 8 times h minus y over h. Integral. And what's y going from? It's going from 0 to h. Let me plug in what h is. It's pi times 8 times h minus y over h all squared dy. And h, I said, was 12 inches. H minus y over h. Okay. Now, what I would do is factor out the constants. Pi times 8 over 12. Pi, 8, 12. And 4 goes into both of them 2 and 3 times. So 2 pi over 3 times the integral of 12 minus y quantity squared dy. Now, you can square that out or you can make a substitution. I'm going to make a substitution, and to make my life easier, I'm going to call that y minus 12. Because when you square it, it doesn't matter. And how about we say let u equal y minus 12? Well, then du will be just dy. Well, that's easy. So we have 2 pi over 3. Y minus 12 is u squared, and dy is du. Now, the limits are y goes from 0 to 12. Y goes from 0 to 12. But we don't have y anymore. We have u. Well, if y is 0 and y is 12, if y is 0, then u would be negative 12. And if y is 12, then u would be, let's see, 12 minus, oh, it'll be 0. Okay, so instead of 0 to 12, we go from negative 12 to 0. Interesting. So we have 2 pi over 3 times u cubed over 3. Just want to see how I can argue that. Okay, so it goes from negative 12 to 0. I'm no longer panicking. So you have 2 pi over 3. Well, I'll factor out the other 3 to make it 2 pi over 9. So we have 2 pi over 9. U cubed. Well, you get 0 cubed, and then you get minus negative 12 cubed. Well, 0 cubed is 0 minus 12 cubed. That's a negative times a negative times a negative, which is a positive. And I'm not going to multiply out the 12 cubed. I'm going to wait for that. So what's in here is just 12 cubed divided by 9. One of the reasons is 3 goes into one of the 12s. Okay, so now 12 times 12 I know. So instead of doing 144 times 12, a 2-digit number, I'm just going to do 144 times 4. You know, in fact, it's such a small number, we're only multiplying by 4, I can add them up. There are 4 4s are 16, and then 17, and then 5. And then I have to multiply by 2. That's going to be 1152, I guess. 15. Yep. It's going to be 1152 pi over 3. And that's the answer to that problem. Okay, we had to use similar triangles to get the equation. To get r in terms of h. Right here. You give me h, I'll give you back r. This completes the section on volume of solids with known cross-sectional area.